सभी को नमस्कार। आज का जो हमारा टॉपिक है दैट इज डिवीजन एल्गोरिथम फॉर पॉलिनोमियल्स। यूक्लिड डिवीजन एल्गोरिथम वी हैव ऑलरेडी स्टडीड in which we applied the division algorithm for integers, but there is division algorithm for polynomials also, that if px and gx be two polynomials where the gx is not equal to 0, that means the polynomial gx which will act as a divisor should not be 0. Then there exist unique polynomials qx, that will be the quotient polynomial, and rx, that will be the remainder polynomial, such that px is equals to gx into qx plus rx. Px equal to gx into qx plus rx. That means if px acts as a dividend and if px is divided by gx, where the polynomial gx acts as a divisor, then there will be a unique polynomial qx which will act as a quotient, and a polynomial rx will exist which will acts as a remainder polynomial. So dividend is equal to divisor into quotient plus remainder. So this is nothing but it is actually the long division process in case of polynomials. So it is the division algorithm for polynomials is actually the restatement for the long division process in case of polynomials. Now two cases arises here. Either the remainder rx equal to 0, that is it's a 0 polynomial, or if rx is not equal to 0, then in that case the degree of rx, that is the degree of the remainder polynomial, should be less than the degree of the divisor polynomial. That means the degree of remainder polynomial should be less than the degree of the divisor polynomial. So if the degree of the divisor polynomial is 2, then it should be either 0, the degree of remainder polynomial should be either 0 or it should be 1. Now some important facts. If rx equal to 0, that means if the remainder polynomial is a 0 polynomial, then you can say that this term will vanish and we are left with px is equal to gx into qx. Then this tells that both gx and qx will act as a factor of px, that gx will also be factor of px and qx will also be factor of px. For example, let px equal to x square minus 5x plus 6. Then x square minus 5x plus 6, if it is divided by x minus 2, then the quotient comes out to be x minus 3 and the remainder in that case will be 0. So here the rx is 0 and this is your what you call the divisor polynomial and this is your quotient polynomial. So in that case you can see that gx, that is x minus 2, is also factor of px, that is x square minus 5x plus c, and x minus 3 is also factor of x square minus 5x plus c. So we can say that if rx equal to 0, then both gx and qx will be factor of px. Next important thing, that the degree of px, that is the degree of the dividend, will be equal to the degree of the divisor and plus the degree of the quotient. For example, let px equal to x cube minus 4. If px x cube minus 4 is divided by x minus 1, then the quotient comes out to be x square plus x plus 1, and in that case the remainder will be 3. The remainder will be minus 3. So in that case you have seen that this is the polynomial px, x minus 1 is polynomial gx, x square plus x11 is the polynomial qx, and the remainder is minus 3. That is, remainder polynomial is actually minus 3. So what we have seen, the degree of px is 3, the degree of qx is 1, and gx is 1, and the degree of qx is, that is 2. So 1 plus 2 equals to 3. That means degree of gx and degree of qx, the sum of degree of gx and the degree of qx is equal to the degree of the dividend polynomial. So from here we have seen the degree of gx is all, the degree of gx is less than degree of px, and degree of qx is also less than degree of gx. So we can write that degree of gx is less than degree of px. That means the degree of divisor is less than the degree of dividend. And second, we can also write that degree of qx, that is the degree of the quotient polynomial qx, is also less than the degree of dividend polynomial px. So from here we get these two results. Now if we divide, suppose px equals to 7x plus 14. If 7x plus 14 is divided by say x plus 2, then the quotient will be 7 and remainder will be 0. So in that case, since the degree of qx is 0, is a real number, so its degree is 0, and in that case the degree of gx is 1. So what we have seen, that if the degree of qx becomes 0, then in that case the degree of gx is equal to degree of gx equal to degree of px. So we can say that the degree of gx can be equal to degree of px if degree of qx equal to 0. That is, if degree of qx equals to 0. Similarly, we can also modify it like this: if 7x plus 14 is divided by 7, then the quotient will comes out to be x plus 2 and remainder is again 0. In that case, the degree of gx is 0 and the degree of qx is 1. So in that case, the degree of qx is equal to the degree of px. So we can say that the degree of qx will be equal to degree of px if degree of divisor, that is gx, equals to 0. So these are the few important points that we have studied. The first one is, if remainder comes out to be 0, then this term will vanish and we are left with px is equal to gx into qx. Then in that case, both gx and qx individually will be factor of px. And second, the degree of dividend will always be equal to degree of divisor plus degree of quotient. Okay, will be equal to the sum of the degree of divisor and the degree of quotient. And thus we can say that the degree of divisor individually will may be less than or equal to the degree of dividend polynomial, and degree of quotient polynomial may be individually less than or equal to the degree of dividend polynomial. So these are the important points which you must know. So that's all from my side, and very soon we will come with the next parts of the division algorithm of polynomials. Thank you.